I think you all have a pretty good idea of what a point is. Okay, we talk about, you know, a point in space here, or I'm going to make a point, you know, to you when I'm making a presentation. I'm going to make a strong, powerful point. So we use the term point in our everyday conversation, but in geometry, and again, we're going to be defining a lot of terms. The point is literally just a dot. Okay, that's really all it is. It's just a dot. Okay, so in geometry, when you refer to a point, here's a dot. Okay, we're going to call that a point, and we're going to give it a label because, you know, we're going to have a lot of different points, and we're going to have a label. So this point right here at this location on this marker board is right here, and that is point A. Okay, point A. You can have another point, you know, over here, and we can call that point B. Okay, so you put a dot and a letter here, right? And the letter is just a label. And you can have another point over here, you know, you can call that point S. Okay, so you can define lots of points. This concept isn't very hard. A point here, a point here, point here, point here. Okay, those are on a plane. You know, in three-dimensional space, I can have a point right here at the tip of my finger, a point right here, tip of my finger over here, and so on. And I just label those points A, B, C, D, E, F, G, whatever, in order to be able to reference them as I go along. Okay, so the next thing we're going to talk about is the concept of a line, which is the next most complicated thing in geometry. But again, it's not really that complicated. I mean, I think you all know what a line is. You know, a line is something that goes on and on in one direction, right? This way, here, back and forth is called a line. Or I can point my finger over here, this way, backwards and forwards, that's another line. I can go up and down, that's a line. So a line is just something straight. I mean, that's just the simple language we have here. But in geometry, we need to define it, you know, really precisely so that we all know what we're talking about. 2 points define a line. Okay, and we're going to talk about this here in just a second. 2 points define a line. A line goes on in both directions through the 2 points that define it, these 2 points here. All right, let's talk about this for a second. Okay, this is a great example of a really super simple concept, but if you were to read this in a book, you've got all these words about points and lines and directions and everything else, and it can seem complicated. It's really simple, okay? All that we're saying here is if you have some line, okay, I'm going to say there's a line right here. Okay, it goes on back and forth here, okay? I'm going to put an arrow on this line on both ends, okay? Because I'm just trying to remind you what you already know, and that is that a line goes both directions. It goes in both directions, and this arrow means this line goes on forever, up like this, and this arrow down here means this line goes on forever, down like that. Now ask yourself, what information do you have to have other than this picture to define a line, okay? What do you need to define a line? It takes 2 points to define a line. Let me just show you what I mean. If there's a point here, right? Let's call that point A. Let's just a label, that's all it is. But here's a point in space right here, okay? And there's a point here, we're gonna call that point B. Any 2 points that I pick, okay, I can draw a line through them. And these 2 points are all I need to define that line. I pick a point here where the tip of my finger is, and I pick a point here where my other finger is. And as long as I know those 2 points, I can take a ruler or a straight edge and I can draw a line through them, and then that line can just go on forever and ever and ever. As long as it goes through those 2 points, I've defined a line. So 2 points is all I need to define a line. Okay, so that's important. So it goes on forever this way, it goes on forever this way, and these 2 points define the line. So how do you write this down? You know, we said for a point, when you have a point, we just draw a dot and a letter, and that is that's how we represent a point. For a line, we're going to write this. Okay, we're going to write this like this. This line is represented by the two letters A, B, with a little symbol on the top. Okay? So what this is saying is, this line is defined by point A and point B, okay? And this little symbol up above just means it goes on forever and ever and ever in both directions, which is exactly what we have here, okay? Now you can also write it as BA, again with the same symbol. So what I'm trying to say here is, when you have 2 points that define a line, you just write the two letters down and put the symbol on the top that shows that it's a line, and it doesn't really matter the order here, okay? You just put AB or BA, it doesn't really matter because the 2 points here are defining the line, and the line goes off in both directions forever and ever. So when you write it down, you can put AB or BA, just make sure you have this up on top, and everybody will know you're talking about a line that goes through these 2 points. Okay? Now, one more thing I want to talk about before I go on is that a point is infinitesimally small. What that means is a point, when you really think about it, has no dimension, okay? We talk about the fact that we live in a three-dimensional world, right? What does that mean? We have length, width, and height, okay? That's the three dimensions, the three spatial dimensions that we live in, right, today, in this world that we live in. But a point, by definition, even though we're putting this dot on the board, and the dot, you know, it's a fairly big dot here, but when we really mean, when we talk about a point, is it's just this place in space. It doesn't stretch this way, because if it did, it would be part of a line, right? It doesn't stretch this way, and it doesn't stretch this way. It's just a point. It's just a place in space, so it has no dimension, 0 dimension. So a point has 0 dimensions, okay? A line goes on and on in one direction this way, and in one direction that way. And we call that one-dimensional. A line has one dimension. And when you think about it, we said our 3 dimensions that we live in is length, that's one direction, width, that's the other direction, and height, which is the other direction. Those are the 3 directions in which you can move. That's the 3 dimensions we have. But a line, when you draw a line this way and that way, it only exists in this direction, okay, back and forth. It doesn't go toward you or away from you. It doesn't go up or down. It only exists along the direction of the line, okay? So whether or not the line is pointed up or down like this, okay, or whether or not the line is pointed down like this, or whether or not the line is pointed over like this, or whether or not the line is pointed up or down like this, all of these lines, you know, they go through, 2 points to define a line, but they only exist in one dimension. This dimension here, this dimension here, and this dimension here. They only exist along the direction that that line travels. And that's it. So we say a line, is one-dimensional. Okay, that's what we say. A line is one-dimensional. Okay, now the next thing I want to do is I want to draw a couple of additional examples to give you the hang of the line here and how you would write it down. Okay, let's say you had a line that started here and it goes like this, and it goes through the points S and the point Z. Okay, how would you write this line? This line goes through these 2 points, S and Z, so I would write it as SZ with the double arrow on top, or I could say ZS. Okay, either letter back and forth. It doesn't matter the order of the letters, but I need to have this on top telling me that it's a line. Okay, and then finally, I have another line here. Let's say I have an up-down line. Here's a line right there. It goes through the point D and through the point Q. So it goes through those 2 points. How do I write that line? If I were writing it down on my test, I would say, well, it goes through D and it goes through Q. So I'm going to write those 2 letters down and I'm going to put that arrow on top. Or I could say it's also QD, like this. Okay. So these are some different representations of a line. Okay. You have the 2 points that you're going to write down in your paper, and you have the little arrow on top that shows that it's a line, and it doesn't matter the order of the letters. Okay, there's one final thing I want to talk about lines, and that is that although it only takes 2 points to define a line, you have 2 points here, and then you've defined your line, you can write it down, okay? That is true. But even though that's the case, a line has an infinite number of points. okay? When you draw this line here, or if I get here and I draw this line from here out into the street, okay? All along that line, there's an infinite number of points. If you look at that line, there's a point here, 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 here. So a line, when you think about it, as you draw, well, even if you can just kind of see it right here, even as I draw this line on the board, and you just look at it, it consists of an infinite number of points. Okay, no matter how close I zoom in and look at this line, there's a point here, there's a point here, 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 here. And when I draw a line through all those points, I get a line. Now, it only takes 2 points to define the line, but that doesn't change the fact that the line itself actually has infinite number of points. You can't count them. There's just so many of them there. Okay, that's what we mean by infinite number. Okay, now what we're going to talk about is the concept of array. Okay, so let me write that down. It's called array. Okay, up until now we've defined points, and through 2 points we can define a line that goes on in each direction, both directions, on forever and ever. And now we're going to talk about array. Array is very, very similar to a line, okay, but it only goes on in one direction. That's the bottom line here. So let's say you have a point A, okay, and then let's say over here you have a point B, okay, and then we're going to draw kind of a segment through here, and it's going to go on forever. That's what that arrow means, okay? So this is a ray, okay? A ray just means it's kind of like a line, but it only goes in one direction. It doesn't go in both directions. It stops right here, but it goes on this direction forever and ever and ever, and that's called a ray. So the endpoints are the 2 points that define the ray are A and B, just like before, and it goes on forever here. And just like before here in the, in this part here, you have an infinite number of points. An infinite number of points that make up the ray. Now I'm using some symbols here, okay? And honestly, that's on purpose, because when you read a lot of geometry, you'll find out that they use symbols everywhere. Symbols for angles, symbols for anything you can possibly think of. Okay? Okay, so how would you write this? How would you represent the ray, okay? Just like we wrote down the line and the point. Well, the way you do it here is you write down the 2 points that make up the ray, okay? But instead of putting a double arrow, you just put a single arrow. And this means that the ray starts at A, and it continues on through B, and it goes on forever and ever. So it looks exactly like, you write it exactly the way it looks, okay? Now, you have an infinite number of points here along the ray, just like you had for the line, okay? That means it consists of an infinite number of points, but it only takes 2 points to define a ray. Now, you want to be careful. You do not want to write it as BA. Okay, this is wrong, okay? Because what you're trying to say here, for the line, you could flip the letters around and it didn't really matter because the line went on in both directions forever and ever and ever. But for the ray, it doesn't. It starts at A and it goes through B. So you can't write it this way. You're not starting at B, you're starting at A. So you write it as AB like this. So the best way to look at this is just by looking at a couple of examples. If I had a ray that started at Q and went through S, then I would have like this, right? How would I write that down? I would say that was QS with an arrow on top, starting at Q, ending or going through S, just like this forever and ever. I would not say SQ with a line, with an arrow on top. I would say QS. So you can only write these one way. Okay, now let's say I have a line that starts at N, or I should say a ray that starts with N and goes through the point Z. Then what would I do? How would I write that? It starts at N, so I just write N, and it goes through Z, and I'm just putting a symbol on top that means ray. Okay, so you can see that although it looks complicated, see here's an example of when things start to look like a lot of drawings and a lot of complicated things, and people look at it and sometimes they're like, oh my goodness, I don't understand this. But it really makes a lot of sense. A point is just one place in space. You represent it by one letter. A line goes on both directions, takes 2 points to make a line. You put your 2 letters and your double arrow on top. And a ray goes on only in one direction. Okay, so you have the 2 letters and the arrow only goes in one direction. Okay, now we're going to talk about the concept of a line segment. Okay, and let me ask you a question. We've already talked about what a line is, which is a line goes in both directions forever and ever and ever. Okay, so if I ask you, what do you think a line segment is? I think you could probably guess, well, it's probably part of a line, and a line goes on forever and ever. So a line segment is going to just chop that line off, and you're going to look at it between 2 points. But that's it. It's not going to go on forever and ever. It's a segment of a line called a line segment. So you'll see right here that that just means, let's write it down. It's called a line segment. Okay? And all it means is if I have a point A, right, and a point B, okay, a line segment goes from A to B, but it doesn't go on forever. There's no arrow here, and there's no arrow here. It's a segment of a line. It just goes between A and B, and it stops. That's all it does, okay? So A and B are the endpoints, and of course you have your infinite number of points here in the middle. You have an infinite, this symbol means infinite number, this symbol means number of points, PTS points, and I'm abbreviating on purpose because you're going to see a lot of these as you go on and look in your textbooks. A line segment has an infinite number of points here. If you get a microscope and zoom in on this thing, you'll see that this little marker here, there's an infinite number. You can't count the number of points in here, but it only takes 2 points to form a line segment. Okay, so how would you write this? Line segment. How would you write that? You can write it as A, B, and you just put a line on top. There's no arrow here and there's no arrow here. And I think you can see why, because there's no arrows here. It doesn't go on forever, it just stops, okay? Or you can say BA with a line on top. That means the same thing. AB, BA, doesn't matter because there's no direction here. You're not actually going one direction or another. You're just stopping between the 2 points there. So the order does not matter. So looking at another couple of examples, if you had a G, point G and a point M, and the line went like this, and it's a segment, so it doesn't actually go past G or past M, you would write that. And this little symbol that I keep using, my little double arrow here, it just means look over here, and here's what I'm writing next. Kind of this implies, this is kind of what this means. This implies that you would write it as GM, okay, with the line segment on top, or MG with the line segment on top. So this is not multiplication. This is nothing fancy like that. This is just saying point G, point M, segment. That's all it means. And it's just so we can all keep track of it. So if you had S and T, and the line segment went between S and T, I think you could see that you're just going to have ST segment or TS segment. So same thing. You just put the endpoints down, and you put your little segment thing on the top, and that just tells you how you would write this down. Okay, now we're going to talk about the concept of a plane. We talked about the point, single dot, the line that goes on forever, the ray that goes on forever in both directions, and the segment that just stops between the 2 points. And now we're going to look at something called a plane. And the easiest way I can explain a plane to you is, by the way, we're not talking about an airplane. We're talking about a plane in geometry, okay, the geometrical way of saying it. A plane is a sheet of paper. That's just the way to think about it. A plane doesn't have any thickness. I mean, the sheet of paper has a little bit of thickness, but you got to pretend with me here. The plane in geometry does not have any thickness at all. You turn this plane and you look at it and you see nothing. There's no stretching in the up and down direction. It only goes off like a plane here on the top of a table or on a sheet of paper or something like that. So plane, which is spelled just like it sounds, goes on and on forever on a surface, but it has no thickness. Like a sheet of paper. And it has no thickness at all. So how do you define a plane? Well, it's going to be tough to actually draw a plane on the board here, right? Because how do you draw a sheet of paper? So what I'm going to do to draw a plane is I'm going to do something kind of like this. Okay, this, you have to use your imagination. It's kind of like looking at a sheet of paper kind of tilted over a little bit, okay? How many points do you think it would take to actually form a plane? Well, for a line, it took 2 points, and a line only went this way, okay? But a plane goes not only this way, but also this way in this dimension right here, okay? So it's going to take 1 more point to form a plane. It's going to take 3 points to form a plane. So you'd have a point here. That would be point A. Some point over here would be point B. Some point over here, C. Okay. Once you have these 3 points, you can cut through them with this thing called a plane. It goes on and on forever and ever and ever in all directions around there. Now that may take a little bit of getting used to here, this concept right here. The fact that any 3 points give you a plane. But I guess the way I want to explain it to you is just put your hands out in front of you and just think with me here. If I have a point here and I have a point at the tip of my finger, I can draw a line through them. I think everybody can get that. So how do I form a plane? All I need is a 3rd point, right? So here's two points, line going between them. Now let's say there's a 3rd point, maybe right here, right in front. So I've got my line. Let's say my arm is my line, right, between these 2 points right here. Pick any 3rd point. Let's say the point's right here. Let's do it down so you can see a little bit better. The 3rd point is right here. Now, if I just continue this line like this, I've got a plane, okay? If I put the 3rd point over here, I can go up like this, and I form a plane. If I put the one right in front of it, I can go front and backward, and I have a plane. So no matter where I pick that 3rd point, I can always move this line, cut up and down as a sheet of paper would, and form a plane. So it takes 3 points to form a plane, okay? And the way you would write this down, there's no fancy symbol for it. You just say plane A, B, C. And to be honest with you, most of the time in geometry, you're not going to have to write that down. You're not going to study planes as much as you're going to study the other stuff. Or in some books, if you have a plane, you know, and it may be defined by point A, B, and C, but they may just put an X up here just to tell you, oh, by the way, that's plane X, okay? But usually you see it like this. You see A, B, and C. Now, the other thing I want to say before we leave the topic of planes is that, and just kind of bear with me here, a point has 0 dimension. It doesn't go left, right, up, down, or anything. It's just a point. It's an infinitesimally small point. 2 points form a line, so a line has 1 dimension. This dimension that goes this way, or toward you and away from you, or whatever you want to call it. A plane has 2 dimensions. It has the dimension of length going this way, so it stretches this direction, and it also has this dimension here, which goes in a different dimension here. So a plane has 2 dimensions. And really that's just a fancy way of saying that a plane has some width in this direction and some more width in this direction. Now it has no height, right? A plane has 0 thickness. So you know, it doesn't have that 3rd dimension. You know, the real world has 3 dimensions. The real world has a 3D shape to it, but a plane is not one of those things. Okay, now the final thing that we want to talk about in this section, which is sort of the introductory section of planes, lines, points, things like that, is we want to talk about collinear points and coplanar points. They sound fancy. You know, again, a lot of geometry is just a terminology. Once you get over that, it's simple, right? So I'm going to teach you what this is, and you're going to be proud of yourself because these are some pretty big words, but it's going to be simple. A collinear set of points, collinear, is just points that are on the same line. Okay, that's all it means. You have to ask yourself, what do you think this means from an English point of view? Collinear. It has something to do with a line. That's the linear part. Think about, what is a co-pilot? Co-pilot is the guy that sits next to the pilot, the guy sitting next to the pilot, okay? Co-pilot. So collinear are points. And by the way, when we're talking here, we're talking about collinear points, okay? These are points that are all on the same line together. That's all it means, collinear, on the same line. So if I have some line here, some random line goes on and on in these, you know, in this 2 directions here, these 2 directions, this way and this way, okay? Then this point is collinear with this point, is collinear with this point, is collinear with this point, collinear with this point. So there's an infinite number of collinear points because we already said the line has an infinite number of points, okay? So this is collinear with the next one, which is collinear with for the next one, and collinear to the next one, and collinear to the next one. It's just a fancy way of saying, here's some points. Are they on the same line together? And if so, they are called collinear, okay? So what would an example of some non-collinear points be? Well, if you have a point here, A, and a point here, B, and a point here, C, and a point here, D, and a point here, you know, E, point here, F. Well, these points are not collinear. They are not on the same line. There's no way. I mean, the closest you could get is you could probably say that C and D and B were collinear. These were collinear here, but A and E and F, they're not on the same line. There's no one line you can draw to put all these points on the line. So they're non-collinear. Whereas these are collinear. And the final thing we're going to talk about is what is called coplanar points, okay? We've already talked about collinear points, which are points on the same line. Okay, that's pretty easy. If they're on the same line, they're collinear. So coplanar means points that are in the same plane. So if this were my sheet of paper here, this is my plane that goes on forever and ever and ever like this, but it's zero thickness. So this is a plane, okay? All the points on the surface of this paper, they're all coplanar. But points up here and points down here and points over here underneath and points underneath here, they are non-coplanar. They are not on the same plane, but everything here on the sheet of paper is coplanar. So to draw a picture of that, just to make sure you get it, if this is my plane, okay, and you got to bear with me because you're drawing a plane here on a flat board, then all the points here on the plane, these are coplanar. Okay, and by contrast, if your plane is down here, okay, this is your plane, and you have a couple of points here on the plane, sure, these are coplanar, but I have a point way up here and a point way, up here above, and a point way below here and way below over here. These points, you got to use your imagination here because I'm drawing it on the board, but if this is your plane and this point's above and this point's above and these points are below, they are non-coplanar. So collinear means on the same line, okay? Coplanar just means in the same plane. That's all it means, okay? So we've covered really a lot of the work in the foundations of geometry. We've covered a lot of terminology, and that's the huge part of the whole challenge. Once you learn the terminology and get used to looking at pictures to solve your problems, then it becomes a lot easier and a lot simpler. So we've covered the point, which is a single dot with no dimension at all. It's just something, it's just a physical abstraction. It's right there in the air, but it doesn't stretch in any direction. It has zero dimension. We've covered the line that goes on and, like this, on and on forever. And because the line is constrained to move along this one, back and forth direction, it has one dimension. The plane can move on and on like this, okay, in two dimensions because you can go forward and backward toward you and away from you, and also side to side. So a plane has two dimensions. And then, real life, you have three dimensions, so you can make a cube out of that, and you have the third dimension of height. And we've also talked about the line segment, which is just between 2 points, doesn't go on forever and ever, between 2 points. We've also talked about a ray, which starts at one point, goes on forever, through another point B there, and that's a ray.
Learn anything at mathandscience.com.